Example. Find the zeros of quadratic polynomial x squared plus 6x plus 8 and verify the relationships between zeros and coefficients. So what we need to do, we need to first simplify this expression. So basically, as you can see, we have the quadratic polynomial given as x squared plus 6x plus 8. So I'm going to write it over here, x squared plus 6x plus 8. If we look closely, we need to find the factor of this quadratic expression, where if we multiply the coefficients, we should get 8, and if we add, we get 6. So I can think of some factors such as 1 times 8 is 8, but when I add 1 plus 8, I will get 9. So basically I cannot consider these factors. So I need to find something else. So the next thing I can think of is 8 is equal to 2 times 4, and if I add 2 plus 4, I will get 6. So basically, if I look at the factors 2 and 4, these two factors satisfy both. Addition should be equal to 6 and the multiplication of the factors is equal to 8. So I'm going to consider 2 and 4. So this is my right combination of factors. So I'm going to rewrite this expression as x squared, and I will write 6x as 2x plus 4x, and then I have 8. Now I'm going to take first two terms together and the second two terms together, and if you look closely, for the first two terms, you can see x is common, and the last two terms 4 is common. So I'm going to take x common from the first two terms. So if I take x common, I have x plus 2 inside the bracket, and if I take 4 common, I have x plus 2 again inside the bracket. So as you can see, this x plus 2 and x plus 2 is common for these two parts of the term. So I'm going to write x plus 2 common, and then if I take x plus 2 common, I have x left over here plus, and I have 4 left over here. So basically I got the factors of the polynomial as x plus 2 and x plus 4. Now let's find the zeros. In order to find the zeros, I'm going to equate the first term is equal to 0. So I will write x plus 2 is equal to 0. So in order to find the value of x, I'm going to subtract 2 from both sides. And if I do that, I will get x is equal to -2. And this is my first zeros of the quadratic function. Now the second term is x plus 4 is equal to 0 again. And in order to find the value of x, I'm going to subtract 4 from both sides. And if I subtract 4 from both sides, this 4 will be cancelled out. And I have x is equal to -4. So my second zero of quadratic polynomial is x equals to -4. So my zeros are basically x is equal to -2 and x is equal to -4. Now what we need to do, we need to establish the relationship between zeros and coefficient. So I'm going to do the partitioning over here. So I'm going to rewrite this expression, and if I write the expression as x squared plus 6x plus 8, and I will write that is equal to 0. What I'm going to do, I'm going to consider the general equation of the quadratic polynomial. So I will write ax squared plus bx plus c, that is equal to 0. Now what I'm going to do, I'm going to compare these two equations. So as you can see, x squared doesn't have anything, which simply means that I have 1 next to x. So now you can see we can easily compare these two equations, and if we do that, I can write a is equal to 1, b is equal to 6, and c is equal to 8. Now if I want to find the coefficients of my quadratic polynomial, I will write sum of zeros, which is basically what? -2 and -4 from here. So I will write -2 plus -4, and that is equal to 2 minus negative 4, and negative 2 minus negative 4 is equal to negative 6. And I can rewrite negative 6 as negative 6 over 1. And as you can see, 6 is equal to b from here. So I'm going to write that as negative b, and my a is 1. So I will replace 1 by a. So this will be my negative b over a. So I can easily say that sum of the zeros, which is alpha plus beta, is equal to negative b over a. Now let's find the product of the zeros. So I will write the product of zeros is equal to, my first zero is negative 2 and my second zero is negative 4. So I will multiply negative 2 times negative 4, and if you multiply two negative numbers you will get a positive number, and then 2 times 4 is 8. So I will get positive 8, which is basically 8. And if I rewrite 8, I will write 8 over 1. So as you can see, my c is 8. So I'm going to replace a by c, and if I over 1 is basically a, so I'm going to replace 1 by a, so I will write c over a. So I can write alpha times beta, which is basically the roots of the equation, is equal to c over a. And this is how we establish the relationship between zeros and coefficients of given quadratic polynomial.